very much for coming to this session. I'm super excited to be giving Apex Enterprise Patterns another role for the third time, actually, at Dreamforce. Even more so that we're now moving to an advanced Apex Enterprise session as well. So just a quick show of hands to give me a bit of an idea of how many people are using Apex Enterprise Patterns or have seen the session yesterday. Okay, cool. Good amount. Excellent. Good. Well, things have moved on. Things are evolving. And here's a taster. It's going to be a bit of a rocket ride. I've crammed quite a lot into it. So let's see how we get on and move swiftly through the deck. So just a little bit about Financial Force before we get into the deck. We are 5 years old as of September the 30th. It was about, well, more or less this time 5 years ago, I was at the trade stand in the expo helping sell the software because we were a mere 20 plus employees at that stage. So fortunately we've got a few more employees now at this stage, and I'm able to contribute along with other members of the R&D team out in Force, at Dreamforce in the dev zone. So we've got offices quite spread around the world. Hopefully opening our Sydney office, pleased to announce, very shortly. Our employees are coming up to 400 by the end of the year. And customers also spread around the globe. So we're a very disparate company, but using the cloud and all the facilities available to us to great effect to keep everything moving. So let's get on to the slides show itself. Before we do, there's the session resources. I've not really got that many links in this deck. Really, what I want everyone to do is find their way via the Dreamforce app to the session itself. And on the feed, I'll put any decks, any questions, any answers on there. So everything will go into the feed. So make sure you're following that feed, and you'll get notifications when I share the deck and any other information. We also have a sample application. Many of you that attended the original session will know that I use this as a kind of vehicle to show a fictitious application revolving around opportunities and accounts to take us through a journey of how to use the patterns and the classes in a sort of reasonably sane way of understanding an application. So that sample application is also available on our GitHub site, so you can check that out. And you'll see some of the code that we're going to see in the decks reflected in that sample application. So if you think, well, I'd really like to see that in a bit more in depth, you can dive directly into that GitHub repo, and the sample code you see on the decks will be reflected in that sample repo, plus other samples I just simply haven't had time to include in the deck. So some of this stuff is also covered in my new book, Force.com Enterprise Architecture. The book was inspired by reflecting on the need for cutting a path through how you actually provide enterprise applications on the platform, from packaging them, uploading them to App Exchange, creating user interfaces, extensibility. Really important point about integration extensibility. We're all hearing around the event about the Internet of Things, connectivity. It's really incumbent on us to create applications that are not just have great user experiences, user interfaces, but have great APIs around them as well. So API is as important as a user interface if you're going to contribute to this ecosystem of the Internet of Things in your applications. So really enjoyed writing that particular section of the book. We've also got sections about big data volumes, asynchronous processing, and also arguably a chapter that justifies its own book in its own right, source control and continuous integration. So some thoughts on how to treat your packaging org more or less as a warehouse rather than something you actually do day-to-day development in. Which is a critical sort of mind shift when you're developing large-scale applications with large development teams. So hope you really enjoy reading the book. It is on sale in Moscone South and on Amazon. I will be giving away 20 copies at the library shortly after this session at 12:30 if you want to join me there. So what are we going to cover in this advanced session? What makes it advanced? Field sets in selectors. So FieldSets, it's probably been around in selectors for a while, but I wanted to include it here because I don't really think it's been pushed as much as it needs to be. If you're building any kind of user interface, you really need to consider FieldSets. If you don't, then you're not giving the full power of the platform to the end users and the subscribers that are using your applications. It's easy to use field sets in your UIs, but it's not so easy to figure out how to query the data in the first place. You end up building all sorts of string concatenation logic to bring in those field sets and make sure those fields are queried. So the selectors pattern does have some support now for helping you just simply express the field set that you need. So we'll cover that briefly. I've also got some highlight from some excellent work Chris Peterson's been doing on building queries dynamically using the excellent Query Factory. Going to highlight that as well. You can see how to do more object-orientated building of your queries. Introducing a concept known as application factories for writing generic services, also helping us with writing unit tests using mocking frameworks. So getting some questions now about how we do mocks. We'll be highlighting a session, Jesse Altman, if any of you were at the Financial Force Dev Talks last night, would have highlighted. We've got up on our GitHub site as well called Apex Mocks. So this part of the presentation ties into that. So if you're using Apex Enterprise patterns and you're thinking using Apex Mocks, this is kind of the bridge between the two, help you adapt to using Apex Mocks. Also, we'll talk about some support for object and field level security. It's quite a topical thing within the ISV community at the moment, particularly Salesforce are requiring support for field level security now in their security reviews. And a lot of people in the ISV community asking, well, how is it actually going to be implemented in our code? A lot of the samples that you see on Salesforce are very literal, which would actually not scale terribly well in our code bases if we're littering these individual checks all over the place. So there's been a lot of conversations in the community, and I've spoken to a few people with different ways of doing it and how to do that generically. So not quite got the full answer yet, but I wanted to just highlight the work that's being done to try and provide a generic solution to checking field and object security. So some knowledge as we go through this deck of enterprise patterns already is going to be handy, and some awareness of object-orientated programming. So let's get on with the field level support. It's a very quick overview of what's involved with field level field set support. Essentially have this selector class defined as normal. Define an extra constructor to allow the caller to determine whether they want the extra fields or not. It may be the context of the code, those fields aren't always required. And then simply override the getsobject field set list method and tell it the field sets. And Salesforce has done a great job at allowing us to do that literally, so there's no sort of strings involved, it's compiler checked. Give it the name of your field set. And the base class will take care of the rest. If you construct your field set with a true parameter on the construct, your selector with a true parameter, then it will include those field set fields for you. And you can be happily passing those on to your controllers or any logic that wants to display those fields. So neat little feature supporting field sets in the selector. Just wanted to highlight there. Query Factory. Rather proud of my graphic I found there. I don't know whether it's just me, but it's quite cool. It's a factory. It's got some queries going along. Yeah? Okay. Maybe. Yeah, see? Anyway, introduction. We introduced it back at the Financial Force Dev Talks in June, and it's a really powerful object-oriented way of creating SOCL. Arguably, probably couldn't have been created pre sort of removal of the statement governor. You know, these sort of things cost a bit of time in terms of statements, but we've created it now, and in the sort of world we live in on the platform, the way the governors are, it's quite fitting. There are some reasons why you may or may not use it. Chris Peterson has a great presentation and discussion on it, but I wanted to highlight its features here. It does also do field level and object level security for you as well, which is a neat addition. So essentially, we're all familiar potentially with writing code like this. It's not very readable. It's not very maintainable. There's potentially, if you're not careful, a few bugs in there that are data-centric. You know, maybe it'll introduce an extra comma when it shouldn't do, only in certain conditions. It's a bit fragile, this type of code. It doesn't really sit well with me personally. We'll contrast that with Query Factory. We're using methods and we're using literals to build up that query. And you'll notice the syntax is a bit odd looking potentially if you're not familiar with it, but this is using something called the fluent technique of methods. It's a really nice way of chaining method calls together. There's nothing particularly hard about implementing it. It's just following a certain pattern of the way the method signatures look. but it allows you to basically set up your query factory, and the final statement there asks, the final method call asks us to give us the SQL, and then of course you can pass that SQL or SOQL onto the database to execute. So nice small example of some of the power of that. It does support things like subselects as well. Liz in the audience here is one of the ones responsible for adding that recently, and we've shared that in the open source version. So some neat features. So kudos to Chris Peace and Liz for bringing this to the world. It is really a serious, nice bit of kit. So the query factory is also being used in the selector. You can use the query factory standalone. You absolutely can. A lot of the things that are in the Apex Enterprise library, like the unit of work and this query factory, can actually be used standalone if you want. You can pick and choose the bits that you want. And in the case of the selector, we can use the query factory within that. So in historic sense, you'll have been writing selector code that looks a bit like this. And we've tried to make it a little bit more elegant than the string concatenation thing using the string.format. And that sort of helps, yeah. It sort of looks fairly readable. We can see what's going on there. But then things get a little bit blurry as we kind of need to match the order of the parameters in the list that we're passing into it. So if we contrast that with an example using the query factory, we can see things look a little bit more elegant. So what's happened here is the selector and the query factory have worked together. So in the previous example, I had to tell the query factory the object and the ordering and maybe the field sets that were involved. Because the query factory is being constructed by the base class, it gets seeded with that information already. So when you call the new query factory method, all you need to do is add the fields and get the SQL out of it. So it's being somewhat pre-populated as the query factory from the selector information that you've already given it. So if you upgrade to the latest patterns, this method is available instantly, as is the previous technique. So you can mix and match the two. If you upgrade to the latest library, you don't have to start suddenly sweeping your code to use this new technique. You can start using it selectively and grow your use of it. But I'm really pleased with the way that that has integrated the query factory into the selector. So let's talk a bit about application factories. You can see I got carried away with our graphics thing here. Robot theme there as well. Many of you might know I've been playing with robots this week. So Wikipedia's reference to factories is up here. I've highlighted kind of the key bits of it, creating objects. We don't really know the exact class of the object that we created. You kind of know what the purpose of the need is, but you don't really care who's going to deliver that. You know, you just want to say, I have a need, don't really mind who's delivering that, as long as I get what I want out of it. So these are the factories. Factories can also be used to deliver something called polymorphism, because you might have a certain requirement for it to be implemented in one context and in a different context implemented another way, but yet the way you interact with it is the same. So polymorphism helps us obtain an interface to entities of different types. And we'll see an example of how we've been able to create polymorphic domain classes using the factory and this technique. So, quick overview of what an interface is. How many of you are familiar with interfaces in Apex? Okay, good. Reassuringly good amount there. So, pretty straightforward interface. It probably wouldn't get very far. Generate probably needs a bit more context on it and things like that, but we're keeping it small to get it on a slide. You can see that we have one interface, two domain classes, sales order and opportunities, both candidates for creating invoices, but maybe have their own specialization on how they actually populate that invoice, where they get the information from. The result would still be an invoice. So hence we have an interface which captures the common need, but it applies to two completely different types of objects. So let's explore that a bit further. If we wanted to do a very simple factory using that interface, then we could pass in a list of S objects. We don't really care which type of S objects they are. We could determine the type of S objects in the list and instantiate either the new opportunities domain class or the sales order domain class, and then call the invoicing method regardless on which. So it's a very simple one. There's some obvious error handling missing in that sample before, and he goes, Andy, what are you doing? This terrible code. It is short. It's just to get the point across. So that's a simple factory, a simple way of illustrating how you can use an interface. So that create invoices method is a generic method and passed in a list of S objects, and it will delegate to the appropriate implementation. So an application factory is kind of, as the name suggests, sits at the application level. It's a way you can go to this one place, and it will give you implementations of your interfaces that are application scope. So it struck me in creating this, and I have to confess I borrowed some of this convention from my .NET days. Those of you that are .NET developers as well might remember that .NET has an application scope concept in it. And the separation of concerns that exists in the patterns already are service, domain, selector, and also unit of work. And I had also in mind that we wanted to mock these things, so we'll get to that a bit later on in the slide decks. These are things that we often want to mock out the way so we can do true unit testing. So the application factory really focuses on these application scope concepts such as service, domain, and selector. It doesn't necessarily have to be limited to that, and you could use other techniques to create interfaces and factories deeper within your application logic. You don't have to use application for that. But it seemed that these concepts were high enough in the application architecture to justify being included in an application kind of scope class. So what do we actually need to do to get to the point where we're using this? We need some interfaces or base classes, preferably interfaces. We already have some base classes. If you've been using the patterns already, we know we've got the S-object domain base class, the selector base class. They carry some good functionality. If you've particularly gone wild with OO, you might have your own domain base classes that even extend the S-object domain base class. So we're really focusing on interfaces as being the vehicle for helping us provide this factory. And then, of course, we need to implement the interfaces and then finally have some factory classes that are able to get hold of the implementation. So the reason that we're going to create these is we do reduce the coupling between the implementation classes. Instead of explicitly instantiating a selector class or explicitly instantiating the domain class or the service class, we're going via the factory. And that gives us some possibilities to create more generic code, as we sort of saw a very basic example just then, and also gives us a way of mocking dependencies between things. And ultimately, for more advanced uses, maybe gives you the way of saying, well, I've kind of got this implementation of my service if maybe multi-currency is enabled, and I've got this implementation of my service if it isn't. You know, some different contextual things might drive your decision to instantiate one class over another. But yet the caller is unaware of how you're instantiating that class because the factory deals with figuring out what type of implementation is required. So it reduces coupling within your code base and creates nice contractual boundaries between those layers. So we've done some work in the Apex Enterprise Patterns library already because we need some base interfaces. Just as we have base classes, we have the IS-object unit of work, IS-object domain, and IS-object selector. And those carry methods very similar to the classes, in fact identical to the classes already. So this gives us an interface into those types of classes. Likewise, we'd want to express our business functionalities interface as well. opportunity service, opportunities, opportunity selector, all expressing the different business behaviors of our application through interfaces. Those interfaces do extend the base interfaces as well. Once we've created those, we can implement the interfaces. Again, very small examples to fit on the slides. We take the service layer and implement the interface in a separate class. And the name of that class is kind of up to you guys, but I've kind of used import. It's kind of a throwback to my Java days. Like they used to use that convention now and again. And obviously, it moves it away from the main service class that we've been putting our static methods on. Those still exist as a main entry point to the service. But we need to implement the interface, and you can't well do that on static methods. So we've moved that across into another class. Obviously, the domain and selector classes, regular classes, and we'll just add that implements method, implements keyword onto those classes. So now all of a sudden, we've got all these classes that can actually behave as per these interfaces. The unit of work carries its own interface, And in the past, we used to construct a unit of work explicitly over and over again and configure it potentially the same way each time. This encourages to create a unit of work in one place in your application class, and then there is a factory method, application.unitofwork.new instance, that will give you that application factory. So whenever you add new objects to your application, you can go into this place and insert them in the appropriate order. Of course, we know that that has to be the order, the dependency order of the application of those objects. Same with service factories. We need to be able to put the service factories into the services into the factory as well and have interfaces expressing those. So we're using this technique to say, for this interface, this is the implementation of the interface. And the usage is pretty similar to the unit of work we've just seen down there. Likewise for selectors, I have seeded some useful functions on the selector factory, which means that you don't necessarily need to instantiate the selector or even use the selector interface. You could say select by ID, and if you see the first usage example there, we don't actually instantiate the selector. The framework takes care of getting hold of the selector and making sure it selects the right objects with the right fields populated with the field sets, etc., etc. And there's also a utility function on there which selects by reference that I haven't got on the screen. But if you do want an instance of the selector, then you can use the new instance method and then go on to actually call the methods on it directly. So what we're seeing here is the same sort of way that you've been using the patterns already, but you're indirectly going through the application factory. So this will become more obvious when we get into the unit testing approach and also the example. So here's the domain class equivalent. If you need a new instance of the domain class, call the new instance method, pass in your records, and that will construct you an instance of your domain class. So you can see that we're not referencing our classes anymore. We're referencing the interfaces. The calling code doesn't know which class implemented that. And that's really good because you can switch that in and out. You can rename it, move it somewhere else if you wanted to. That's the reducing of coupling point we were making earlier. So a service implementation still looks pretty much as it was in that you have a class and you have a static method and you might construct a unit of work. This is kind of the older version, isn't it? Yeah, that's what we're looking at here. This is traditionally what you would do. Most people, if you've been following the guidelines and the patterns, that's pretty much what your code would look like. In the new version of it, it looks a bit like this. Essentially, it's become a bit of a stub. The service method is just a stub, an entry point into your service. It's got all the same methods on it, but it's delegating to a service method which actually resolves the actual implementation of the service for you. So you never expose that method. It's a private method on your service class. And because it's using the interface, and the interface is modeled after your methods on your service, it's a direct mapping. So it's not really that difficult to create it, possibly a code generation opportunity there maybe. But that's what the application service looks like. No change to the outside world, and that's kind of one of the goals for this. Wanted to make sure the outside world didn't really notice that change. So when you actually implement your service, the code is still much the same, except that as a class, you've got this impl class. You're implementing the interface, and then you're using the unit of work factory to get hold of the unit of work, doing your work and committing it. So pretty much business as usual, except that you're using an instance of your service class and you're using that unit of work factory to get hold of that pre-configured unit of work. So here's that generic polymorphic example I was referring to earlier. This is kind of taking all of those concepts and using them all at once. We have a requirement to have an invoicing engine in our application. We want to have some common logic around invoicing, how we generate the invoices, what happens to the invoices afterwards is the same regardless of what object what the source object was. It could be an opportunity, it could be a quote, it could be a work order, it could be anything. So the engine here, this invoicing engine that's been built, is saying, right, I'm going to use the selector factory to get me the records. I don't know which selector gives it because I don't know what type of records they are. And then I'm going to pass those to the domain factory. And again, I don't really know what domain class. I don't really care which domain class serves this. As soon as I've got that, I'm going to cast that. I'm going to determine whether that implements my interface. If it does, then I'm going to go off and actually do the generate. And a bit further down, it will throw an error if you pass in some S-objects that don't support that behavior. So it'll say, hey, this source object does not support invoicing, something along those lines. So that's a way that we've used polymorphism to actually create generic services within Salesforce, within Apex. So finally, let's move on to, we'll say finally, we've got the field level security to go yet, but unit testing and mocking. Now again, a session in its own right. Jesse did a fantastic job last night. We weren't fortunate enough to get a full session at Dreamforce this year. We'll try again next year. Anybody in Salesforce listening? Unit testing and mocking, really excited about it. So let's get the Andy Fawcett whistle-stop tour of it. So this is Wikipedia's, you can tell I'm a big customer of Wikipedia, can't you? This is Wikipedia's reference. We're not going to read it all, but we're looking at small testable code, individual functions or procedures, an interface, individual methods, short fragments, those sort of terminology. How many people in the audience can relate to that when they're writing Apex tests? Okay, not surprisingly small amount of you, because really, you're not really doing that. What you're doing is something more akin to what an integration test is. So typically, in an Apex test, it's required that we set up lots of application data before we call the method. We have to insert the data in the database. It has to be valid. Then we call our methods. Then we have to execute code we don't really care about because we've just added a new method to our controller or our service or domain layer. And it's gone through all this other code path to get to that point that we want to test. So often, because the tests end up taking so long to run, we end up getting a little bit deterred at writing more variants of those tests, because it's always great to throw different data scenarios at your tests. It makes it more robust, gives you more confidence as the code evolves over time. But ultimately, you reach a point of, yeah, it's taking 5-10 minutes to run this test. I really can't write any more tests. So it starts to feel like we're writing integration tests, which is a perfectly valid thing to do in Apex. You need to do that. So this message that I'm giving here isn't to say don't write these tests. You absolutely need to write them. For one, you need to cover code in your triggers. This unit test mocking approach I'm about to describe does not cover that. You'll need coverage in your triggers, even though they're the one-line triggers we have with patterns. But the benefit of using unit testing is that you can be more varied, you can be more targeted, you can do something called test-driven development more easily. So before we have a look at what that looks like visually, this is what we've really been doing to date. It's called integration testing. We interact with a database, we create test data, we read it from the database, and we absolutely do require it. It's needed to cover triggers. And also there's platform behavior involved. The unit testing mocking approach doesn't use the platform behavior. Sometimes, as we all know, triggers go off in different orders depending on workflows and things that are in place. So you absolutely need to bear in mind there's a place for integration testing as well. With all that said, this is kind of what a unit test approach would look like. When we're writing a unit test for a controller, we just want to test that controller, the code in that controller. If it happens to depend on a service, we assume that service itself has been tested by another unit test, which it has on the right, in the middle tier here. There is a unit test for that. When we're testing the service, we don't really care what the domain code does because we've written another unit test for the domain code. So we're specifically targeting each and every layer with very fine-grained, tailored tests for each and every layer. And in combination, they all effectively cover the code. And in some cases, quite a lot more than traditional approaches allow us to cover code. So we're using something called mocking, which is essentially providing an implementation of the particular service, unit of work, or domain layer that's kind of just a null version of it. It doesn't do anything. And that it also records those combinations of communications between the components, so you can test those communications. So if I was writing a controller test, I could say, did it actually call the service? How many times did it call the service? Did it pass the right information to the service? Those are things I'd be interested in if I was a controller developer. If I was a service developer and writing a unit test, did it actually register that with the unit of work? Did it call the selector? When it called the selector, what data did it give back? These are questions that I want to test in my code. And some of those are what's known as behavior-driven testing, which is also an interesting concept. Most of the time we do data-driven testing. We read something off the database and we assert the values. That's all well and good, but sometimes you need to do behavior-driven testing to assert whether or not the software, it might be doing its job, but is it doing it the way you originally intended it? For example, you might get the right answer, but it might have called the method 3 times, completely superfluously. So with the frameworks like this, you can actually assert behavior and say, called the service layer once, didn't it? Oh, no, it called it twice. Oh, what's going on there? Is there a bug in the controller? These are the sort of bugs you might not actually see because the data actually, the result was actually what you intended. So it's about all really I can afford to cover in allowing time for questions on the fabulous Apex mocks. It is covered, is very much inspired by Mockito. How many people are aware of Mockito in the audience, just out of interest? Yeah, a few of you. And it's well worth a look. Paul Hardacre, massive kudos to him. He's a developer, works in our UK office. Hardcore Java developer came to us just over a year ago and wasn't particularly pleased with the unit testing approach on Force.com, so this is the result of it, and I'm very pleased. His blog is there, there's his Twitter handle. He's actually back in the UK with a bit of a poorly leg, so regrettably couldn't be here to join us in communicating this, but do take a look at it, and I'm sure he'd love some tweets and some feedback once you've taken a look. It shares similar syntax with Mockito. That was his vision, and he's done a really good job at making it look like Mockito. So here's a very simple example. You'll notice the convention of the method names different as well. I quite like it. It took a while to get my head around it because you end up with massive method names, but they're quite descriptive. So calling apply discount on controller should call service. This is a behavior-driven. So we obviously set up our test data, but it's in memory. We're not inserting it to the database. Create the standard controller on line 8 and 9. Then we create a mock service and set that mock service on the application factory. Because we don't want the real service to be called, because if it ends up calling the real service, it's going to expect a real opportunity on the database, and it's going to expect all sorts of things that we're not interested in. All we want to know is that when you call the apply discount method on the controller class, that it called the service once and with the value 10. So that's the Mockito syntax that you see at play there. Aside from the cast on line 20, line 21 is pretty much Java Mockito syntax. Verify that the service was called once, apply discounts was called, and it got past these parameters. So that is a very specific, very tight unit test on that controller. No more, no less, just on that controller. So we've just got a few more minutes just to talk about field level security. It is a requirement now of the Salesforce security view. The challenges for us as developers is that how do we implement it consistently, accurately, and with minimal overhead? How do we implement it retrospectively? There are some solutions, but none are forthcoming at present from the platform. I, for one, am lobbying Salesforce as hard as I can for a with FLS keyword or whatever, however it might transpire, user mode or something like that, so that we can leverage field level security through platform support. Until that arrives, we do have to do the work ourselves, and those of you that are familiar with object and field level security will know the syntax for doing it. One of the problems with doing it that way is you end up putting that all the way through your code base and maintaining it and having to test it. So there are some discussions, and I've put the links there where it says here and here, that have been occurring in the Salesforce developer forums about ways to do this generically. It's not straightforward, but it is possible. There are some pros and cons to it. So it is really much an experiment at this stage. Really welcome some input on it. But the current experiment that I've come up with doesn't require any changes to your code. If you're currently using Apex Enterprise patterns, what I've done is I've hooked into the unit of work and domain layers. So there's some inception points when you're using those layers that will reach out and do the FLS checking. So there's a small UML diagram to show how that works. It uses another excellent Chris Peterson contribution called Security Util to do some of the security checking, which in itself can be used quite well. If you don't like any of this, check out Security Util. It's a really nice wrapper around checking FLS and object security. So the experiment was partly successful, but there was some challenges. One of the challenges is when we have S objects in memory, to write a generic library to check what fields have been edited is quite hard. You can't just ask an S object what fields have been modified. You can get and put fields on an S object, but you can't actually say what's been changed, which is quite a core requirement to writing a library for FLS. It turns out that triggers do help us a little bit, because obviously triggers passes the old and new. Chris actually contributed to the discussion and realized that if you serialize using JSON and deserialize, you get the fields that have changed. So it is a bit of a hack. Yeah, it is a bit of a hack. Performance will not be great, so that's why this is currently in sort of research experimental stage. There is another developer that approached me just the week before Dreamforce that may have cracked this with an algorithm by determining the field types and certain other attributes on the fields. So that might be something I'll be looking at in the coming weeks to see if we can remove this JSON serialize fly in the ointment. But anyway, that's some thoughts on how the enterprise patterns could attack this FLS problem in a generic way. And if we do manage to solve that, then that'll be a zero-code change to anybody that's using the patterns. So in summary, we have basically leveled up the application enterprise patterns with some help from the community. It's great seeing now there is a definite surge of creativity and input from people contributing to the patterns. So those of you in the audience, we recently celebrated those on the Financial Force blog. Thank you, if you're in the audience, for contributing to the patterns. We really appreciate it. And also, thanks go out to Chris and Liz and Paul for their contributions to the patterns as well. So a final reminder that all of this deck and any other questions and things can be answered via the feed. So at this point, I'll take a few questions. We've got about 3 minutes to do that. I think there's some microphones dotted around the room. Thanks very much.